All right, so we're going to look at the graphs a little differently. We're going to look at them instead of terms of 2 pi's and pi's. We're going to say what happens within one period. And so for sine, we're going to look at that within one period, this graph does a lot of different things. It goes up, down. Let's point this out. At the end of it, that side is on. At the end of it, it gets to 0. It starts at 0, so just like on the unit circle. And halfway, it's also at 0. Sine goes up to the maximum point at a quarter, and then down at the 3/4 mark. And that's going to be pretty important. Let's contrast that with cosine real quick. And cosine kind of starts and ends at the top point, and in the middle goes through 0. And at that quarter and 3/4 mark, it hits the zeros. So let's go ahead and look at a sine and cosine graph that doesn't have a period of 2 pi, and how do we approach it? So let's say we were trying to graph y of cosine, and let's throw a coefficient in there. Let's call that 3 cosine, and we'll even do something kind of funny. Let's call it pi halves x. So before we even graph this, what we're going to do is we're going to go ahead and we're going to figure out the period. And the period is always 2 pi over b. So in this case, when we do that, it's going to be 2 pi divided by pi halves, which is the same as 2 pi times 2 over pi. So the pi's will cancel out. And so what we're left with is a period of 4. What that means is that this point over here is going to be at 4. The halfway is at 2, quarter's 1, and that's at 3. So we can use that information now to produce our own little graph. So we're going to go ahead and make some axes here. And so we're going to say a full rotation of this is going to happen at 4. And everything else, we split it up like that. And now instead of the max, since my amplitude is 3, I'm going to go to 3. And I'm going to set that up at the halfway point. I'm going to the minimum point, so -3. And then I get my little zeros in here. And so we'll have like that. And it would continue on. It would just do it over and over again. That would be a nice like cosine. So what about sine? And let's do one that will end up still in terms of pi. Let's say if we had sine of, let's call it 3x. And let's go negative sine, okay? That'll make it just a little bit different than what we did before. So the period is going to be 2 pi divided by 3. Now that makes it a little bit funnier. All right. So let's go ahead and we're just going to leave it like that. And I know that's really uncomfortable, but we'll try it. Let's see. So in this case, what I have to know is that 2 pi over 3 is going to be the ending point. And then I'm going to need to know what the middle in each of those are. There is a fun trick to cut a fraction in half, which is double the denominator. So that's going to make this 2 pi over 6, which simplifies. So this we probably could have done this a little easier, but 2 pi over 6, whoops, that was too big of an eraser, is going to be the same as pi over 3. So we'll call that pi over 3. And again, let's use that trick again now. That half of that is pi over 6. So I just double the denominator to make halves. It's a little fraction math there. Now sine's still going to start at 0, still going to end at 0, and in the middle is still going to be 0. But since this is negative, we're going to just go the opposite direction. So instead of going up first, we're going to go down and then up. And since that was just a negative coefficient, we're just going to call this -1 and +1. So let's look at the Khan Academy assignment and see how weird that got. So as we look at this, oh my God, there's some extra stuff in here. But still, we are going to focus in on finding what the period is. We're going to deal with this -7 afterwards, actually. Let's just ignore that for a moment. So we're going to just graph 2 sine of pi tenths x. So the period here, 2 pi over pi tenths, is going to be the same as 20. That's crazy. 20 is not even on this graph. So what I'm going to have to imagine is that 20 was on my graph. And that I have 10 here. Oops. Woo! And 15 here and 5 here. Now, sine, again, still going to start at 0. Still going to be in the middle there. And since it's positive, it's going to go up to 2 in the quarter work and then down to -2. So I don't have those points necessarily on this. So I have to kind of adjust a little differently. So I'm going to still start at 0. And now it looks like at 5, I'm going to hit my maximum point, boop, up here. And that set it up. So this little extra dot right here that I'm moving is the quarter mark. So I moved it right there, and boom. Now, there was a down 7 in this. It wants me to move everything down 7. So let's just move these 2 points down directly 7. So from 5 to that. And let's check it. And oh no, I made a mistake somewhere. So let's see where I made a mistake. Let's make sure that my amplitude was 2. So let's go back. 2. And we had determined that we were going to that. Oh, I moved that all the way up to 5. That was my mistake. This should just be down here at 2. Amplitude is 2. So if we make a mistake like that, that's life. So notice now my amplitude is 2. So I'm going to move this down from 2. I'm going to move it down 7. So that's going to get me to -5. Move that down. Look at me go. I did some math. Now here's a big one again with cosine, okay? So again, I'm going to kind of ignore this -4 for the little bit. I'm going to figure out the period, which is going to be 2 pi over 16ths. So you can kind of, again, notice we can multiply the 16 times the 2. We could do long math, but let's do short math. 32. So I'm going to, again, put on my vision board, half, I don't even have to really know. Oh, let's get that point in there. And this would be 24. And so if this was just straight up cosine, it would start at 1, end at 1, and in the middle hit its minimum. So it should look kind of like that. But notice that this puppy is negative, so we have to reverse it. So let's start at the bottom. So we're going to start down here, and then we'll hit the maximum in the middle, and we'll also end up at the bottom there. So this, if this was -5, would be my parent graph. So let's get that going. So notice the hump is over here. So I think we can kind of drag this so that these are in opposite spots. So I'm going to drag that to -5, and it looks like I missed a little bit when I drew this graph. This should have gone through that. That's much better. Okay, so let's get a little, oops. So this should have looked a little bit more like this, going through 8 and 24, like that exact way, half point. So at 8, it looks like I'm supposed to get that point, and I don't fit the rest of the points in. So that's kind of a weird scaling that they chose. Now we just move everything down 4. So we're going to take that -5, go down 4, take this one, down 4, check. Look at me go.